All right, everybody have your notes labeled? Yes. Okay, looking around, yes, 8.7. All right, so with function notation, the good thing about function notation is that it is pretty much identical to a linear equation. So linear equations, I'm going to write down here kind of midway down the screen. We would write them as y equals x plus 2. This is something that we've been doing in chapter 8. Y equals x plus 2, so we know that that's in function form, or what we call slope-intercept form. Well, function notation is basically the exact same thing, except now it's going to substitute in this term called f of x. All right? Now, the f is simply a label, or it's naming the function. Sometimes you'll see an f, sometimes a g, sometimes an h. It could even be a different variable. That doesn't really matter. It's kind of like a label. All right, so you know you have inches or feet. Well, this is the label of the function. All right, so f of x, and you see right here in the paragraph below, replaces y in the same type of equation that we've been solving in chapter 8. So the good news is when I graph a function, that's very similar, if not identical, to the way that I graph equations. So that should be, not too bad. All right, so you do also need to know how to read them. This f of x right here, that's exactly how I read it. I would read it f of x, a function of x, or a function at x. So that value, for instance, f of 3 is the value of f when x equals 3. We're going to talk more about substitutions in example 1. All right, so I just need you to kind of soak in and at least write down this middle part right here, that a linear equation, and I think I even wrote it, right over there on the whiteboard. Linear equations is the same format as a linear function. All right, they really go hand in hand. I'm just substituting in the f of x instead of y. All right, y'all ready for example 1? You don't have to write down everything on that screen. I know there's a lot. Okay, so in example 1, I'm working with function notation. What does that mean? That means that I'm given a linear function. F of x equals negative 3x plus 8. And then I have 3 scenarios. Find f of x when x equals 5. Find f of x, find x when f of x equals negative 22. And find f of negative 4. For all 3 of these scenarios, I'm using the same linear function. Have you written it down? F of x equals negative 3x plus 8. All right, so now I have to figure out, where does this value get substituted? It says find f of x when x equals 5. So this value gets plugged in for x. All right, really the only thing that I see people getting confused is, well, I have an x here and I also have an x here, so where do I plug it in? Here's my best advice for recognizing that. F of x is actually one term. So it will tell you specifically, like you see down here, that f of x equals some value. Okay? All right? All right, so let's make our substitutions. Find f of x when x equals 5. So, negative 3 times 5 plus 8. Does everybody see why I plugged in the 5 there in parentheses? Because that's my value for x. So go ahead and solve it. What is negative 3 times 5? Negative 15. And what's negative 15 plus 8? Negative 15 plus 8, negative 7. Negative 7. Because it's different signs. I know, guys. I know we got to use those mental math skills. Negative 15 plus 8 is negative 7. So f of x equals negative 7. All right? Yep, we're just making substitutions. So as long as you can figure out where to substitute the value, it's probably not too bad.
Okay.
On the next one, it says find x when f of x equals negative 22. So negative 22 equals negative 3x plus 8. For x, got your answers? So subtract 8 from both sides. Negative 30 equals negative 3x. Divide by negative 3. X equals 10. All right, so we just follow our signs for our positive and negative numbers. When you see a number, like on the third one, find f of negative 4. When you see a number in parentheses by itself, it gets substituted in for x on the right side. So f of x equals negative 3 times negative 4 plus 8. Right? Then it's just a matter of getting the math right. What's negative 3 times negative 4? Positive 12 plus 8 is 20. Okay? So just really when it comes down to it, we're just substituting.
So
all right.
just replace it for that x, right?
Mm-hmm. Yep. Exactly. All right, so on example 1 checkpoint, it's a different equation. Now it's g of x equals 4x minus 5. Remember, because they changed it from f to g, that's no big deal. It's just a different label for the function. It doesn't change the way that I'm solving anything. All right, so you have 3 scenarios. Find g of x when x equals 2. Find g of negative 10. And find x when g of x equals 19. Make your substitutions and solve. I'm going to walk around and kind of just check y'all's and make sure y'all don't have questions, and we'll pick back up here in just a minute. Okay, so g of x when x equals 2, g of x equals 3. Did y'all get 3 for the first one? How did I get it? Because I substitute in 2 for x. 4 times 2 is 8. 8 minus 5 is 3. On the second one, g of x equals 4 times negative 10. Remember, if the number is by itself like that, that means that's the value of x. It will have to specifically say g of x equals in order to go on the other side. So 4 times negative 10 minus 5 is negative 45. Okay, on the third one, now it clearly says find x when g of x equals 19. So you plug in 19 for g of x, add 5, and divide by 4. X equals 6. All right, who got all 3? Did anybody get all 3 correct? Okay. All right, so that's example 1 checkpoint. All right, example 2, we're graphing linear functions. The good thing about graphing linear functions is it's pretty much the same thing as graphing a linear equation. What the book tells you to do is instead of f of x, just replace it with a y and rewrite the exact same equation. So now, instead of f of x equals 3 over 4x plus 1, that's the same thing as y equals 3/4 x plus 1. The only rationale or reasoning I can think of why the book would tell you to do this is because this is familiar to you. This should be like comfortable territory for you at this point. Where you see this linear equation, you're like, okay, yeah, I know how to graph that. This was on your quiz yesterday too, to graph a linear equation. We just have to remember it's not truly an equation. It is still a linear function, but it's graphed the same way. Why do you think I drew my graph this way?
Because you don't need them.
Okay, so I can look at the equation and I can go ahead and roughly gauge, all right, are my numbers negative? If they're negative, I need negative numbers on my graph. Are they like really big, especially my y-intercept? Then I need to make sure that I set up my graph that way. So if your space is limited, this is very easy for you to do this. Okay, so go ahead and set up your graph. You can set it up the way that I did it, or you can number it differently. I don't care, but I want you to go ahead and graph this function. Okay, so where does your first point go?
3, 1.
No, your first point goes on your y-intercept. Remember, that's the last number in your equation. That's where your first point goes, at a positive 1. Then, how do you know where to go from there? Rise over run on your slope, 3 over 4. So this means I rise 3 from that point, not from 0, but from that point I would rise 3, run 4, and that's where my point would go, right here. And then draw my line. Okay, so a linear function is literally graphed the exact same way as a linear equation. All right, so well, yeah, that's what your book says, but what I just need on your test, I'm not going to make you rewrite it with a y. If you can recognize that the linear function is graphed the same way, that's fine. Okay, that's just what I need you to connect. You already know how to do this. I'm just putting it in function notation and teaching you the same thing. Okay?
Fx equals y.
Exactly. F of x and y are interchangeable. All right, so example 3 now. In example 3, this mirrors 8.6 in that in 8.6 I needed to write a linear equation. All right, so I want to review that with you. Linear equations before we work on this part. All right, so in 8.6 I gave you 2 ordered pairs. Let's say it was 2, 6. And 0, negative 4. And I said, write a linear equation that passes through these points. You guys remember how to do that? It was on your quiz yesterday. Go ahead and do this. Write the linear equation that passes through these points. We'll go over it. This ties directly into example 3, so I just want to kind of do a refresher real quick, and then we'll finish up example 3. All right, so the first thing we want to do is find our slope. All right, I don't know what's going on here. All right, so the first thing we're going to do is find slope. So that's going to be negative 4 minus 6 over 0 minus 2. So it's going to be negative 10 over negative 2, which is positive 5. So in my equation, it's y equals 5x. And how do I know what my y-intercept is? What's my b? Whichever ordered pair has the 0. So my b is negative 4 minus 4. All right, and that's my linear equation. Who got that right? Who got that right? Okay, so we're on the same page. Now back to example 3. In example 3, they want me to write a linear function now. And the way I do that, oh, I just lost it. Hold on. Okay, hold on. Let me get back over there. Okay, the way I do that is I need to come up with ordered pairs from the function notation that I'm given. So it says g of 0 equals 9 and g of 3 equals negative 6. Okay, so what I'm going to do is I'm going to pull these values out and make them into ordered pairs. G of 0 equals 9. I pull that out to make 0, 9. All right, and I just write it in the order that I see it in the expression. G of 3 equals negative 6. So it's 3, negative 6. Now I've made my ordered pairs, and now I can use the same process that I used to do linear equations to now write my linear function. All right, so I have 2 ordered pairs. Do I know yet what my b is? Do I know what my y-intercept is? What is it? Positive 9. It's the one that's paired with the 0. Okay, now use your ordered pairs to find your slope. Remember, slope of a linear function is the same thing as a linear equation. Okay, so now I have negative 6 minus 9 over 3 minus 0. So negative 15 over 3 is negative 5. Now I have everything I need to write my linear function. So don't fall back into a habit here when you're writing your answer. And I even make the mistake of doing this. I even did it in one of my classes today. And if you were in that class watching this video, you're going to think, she didn't do that in class today. It's because it's that easy to forget. Instead of writing y equals, I don't do that. This is not a linear equation. I'm going to write g of x. Why would I write G? Why not F? Why not H? Why not R?
That's the origin.
Because that's what it is up here in my values is a G value. That's my label for this function. Okay, so G of x equals negative 5x plus 9. All right, and now I've written my linear function. So the sad thing is, if you do accidentally write y equals instead of g of x, it is wrong because you did not write a linear function. You wrote a linear equation. You did the slope right, you did the y-intercept right, but you did not write a linear function. Does that make sense? Okay, let's do one more of these. Okay, so we're now writing our own linear function. Actually, let's do two more of these. We're going to do the second one and the fourth one. All right, go ahead and write a linear function. And guys, this is exactly how you're going to see it worded on your quiz and test. All right, it's starting to make you sound super smart, isn't it? Write a linear function that satisfies the given conditions. I mean, you show your parents that type of question, they're like, whoa, you're really getting good at math. And it's not that hard. It's just you have to know what you're doing. You've got to know where you're plugging in the numbers. All right, so let's practice the second and the fourth ones real quick. And you got to make our ordered pairs, find our slope, y-intercept, and then plug it in and write our linear function. Okay, so 0, negative 7, 6, 5. So 5 minus negative 7 over 6 minus 0, 12 over 6 is 2. What's my b value? My b value is negative 7, so it's f of x equals 2x minus 7. All right, who got it right? Who got it right? F of 0, no. It has to be f of x. F of x, okay? All right, so on the fourth one, but on the quiz, Bryce, you would need to write f of x. Okay? On the fourth one, r negative 7 and 3, 0 and 3. Well, 3 minus 3 is 0. So what is my slope? Is my slope 0 or undefined?
0.
It's 0. 0 in the numerator, so that makes a 0x plus 3, but we know that cancels. R of x equals 3. I would take this first answer for a minus 2. But you've got to know that 0x completely cancels the term. It doesn't make it just an x. That would be 1x. This is 0x. It cancels. This is a horizontal line. You go up to 3, plot your point, and you draw your line. It's a horizontal line. All right. Anybody get that one right? Okay. Okay. So we're going to keep practicing this some more over the next couple of days. Then we'll quiz over it on Monday.